Hello, it's Duncan. Last week we left our hand-rolled JSON parser parsing two sets of tests. The first set are those that we wrote to drive the development of the code. This is TDD after all. These check that we return the right result for progressively more complicated input strings. The second set of tests are the JSON Test Suite tests, designed to test that a parser accepts and rejects good and bad JSON respectively. Those tests are comprehensive, but don't actually specify what output we should generate for each input. Now we'd like to check that our parser returns the correct results for any input, not just those we can be bothered to type in. Luckily, we're computer programmers. We can substitute software for typing. So today we're going to look at programmatically generating test cases. So far we have two types of tests for our JSON parser. The first is in this JSON2 tests, and these are places where we build strings like true or 42 or an empty array or array with things in it that represent JSON. And because we built them, we know what we expect they represent. And so we can check that if we parse something like this, then we get an empty list and so on. In addition, we have some examples in here, things like a string and an empty string and so on, some of which we're using in our JSON2 tests. And when we are, for example, this strings, there, we're not able to say what we expect to find, but we are able to say that for each one of the strings in those examples, then we expect that what we get out is a string. So our strongest guarantees are we know what we put in, so we know what we expect to get out. A weaker guarantee is we know the type of the things that we put in, and so we know the type of the thing we expect to get out. And then there's the JSON Test Suite tests that we wrote last time. They're here. I've tidied them up a little bit since we saw them last, and also made the test fail if any of the examples fail. And these are files with things inside them which are valid or invalid JSON. So here's one, for example, that's valid JSON, I think. We have things like these arrays with a comma and a number, but that's invalid because it doesn't have anything before the comma. And in these cases, we know whether we expect to be able to parse them or not parse them, or in the case of the i's, where it doesn't matter whether we can or we can't, but we don't know what the actual result should be. So when it comes to knowing what the actual result should be, we've only got the tests we've written in JSON2 tests, where we've created a JSON string and asserted that the result is what we believe this is the JSON representation of. Now, all these cases have been best efforts on my part. It would be nice to run our parser against more examples. In order to do that, we could generate JSON from something we knew and check that when we parsed it, we got out the thing that we had put into the generation process. Now, we could write our own JSON serializer, but that would leave us with a bit of a chicken and egg problem. So I think what I'm going to do is I'm going to bring in Jackson, which is, I think, the de facto JVM JSON library, and use that to generate some JSON for us. So then, let's add Jackson to our build. We'll go here and say, hey, AI assistant, add a dependency on the latest Jackson JSON library. I think I'll say add a test dependency. And there we go, it says we want that. I'm not sure I believe that's the latest version, but I'm sure it will do. So we will save that, make sure that Gradle has imported it. There we go. And now let's write ourselves a Jackson tests. Now to write out with Jackson, we need an object mapper. So we'll say object mapper, create one of those. And I don't think we're going to need to be very sophisticated with our configuration of that. So we'll leave it alone for now and write test. And I'm going to call this round trip or something like that, but not tripe. Okay, so let's start with, I'm just going to write it out. Let's say we have an input is banana. Then my JSON is going to be my object mapper, right value of string on my input. And now my parsed result is parse JSON, our own function on the JSON. And now we should be able to expect that the parsed result is equal to the input. Let's run that. Well, it passes, that's nice. I'm always a little tiny bit suspicious. So let's just print the JSON in here, just to give us confidence that something is actually happening. So run that again. Look at the result and, oh, there's banana. So we are passing something, that's good. Okay, let's ramp this up a bit. Let's start with a list of things. So we'll start with banana, which is a string, and we could have true and false and null. And what else do we have? Well, we have numbers. So we could have 1 and -1 and say math.py. Let's try that. And that's failed. And well, we have banana, true, false, null, and so on. And we've got this odd thing here where the expected and the actual appear to be exactly the same. That's a bit puzzling. Let's set a breakpoint after we've parsed the result and see what we actually do have. So here we are, here's our parsed result, and we have, okay, here's our problem. We put in 1 and -1 as ints, and pi, I guess, as a double, but whenever we're parsing numbers, we're outputting a big decimal. This is a big decimal of 1 and -1 and pi. So straight away we've run into a problem with our round tripping, and we have to ask ourselves, what do we want out in this situation? And I think I would probably want 1 to parse to the integer 1, not a big decimal. So I think maybe we'll park this test, go back to our unit tests, and sketch out what we'd like to see. So here's the unit test for numbers, showing that indeed we do parse integers into big decimals. If we don't want that, I suppose we can change what we're asking for. So we can say that this should be equal to 42 as an int. And the same is true for, in fact, these are the two. So let's say those are just 42. And for now, I think we'll say that if there is a decimal point, then we do actually get out a big decimal, or in fact, exponential notation. So we'll run all these tests, make sure that by some miracle they don't pass all by themselves. And no, there we are. And in this case, actually, strict is a bit more helpful. It shows that we're comparing an int with a big decimal. So now let's go off to our parse and see what we can do. Okay, so here on the right is where we convert a literal into a value. Null, true, and false are special cases. And otherwise, we check to see whether the string matches a number regular expression. Now, in the comments to the last video, Yusuf suggested that we can write an operator fun regex contains, like this, and use it in here. Maybe make it private. And that would allow us to say, I think, in regex, rather than if string matches. So that would go like that, and then that would be else like that. Well, that compiles and it's nicer, but we can't really check it works without reverting this. So let's do that for now. Rerun. Everything is happy, and now we can undo our change there. And now what I think we'll do is we'll say, if we are in a regular expression that defines an integer, then we should parse ourselves as an integer. So in here we could say in int regex, then we could do string to int. Now we don't have an int regex, but that sounds like a job for AI assistant. So I'm going to say, write a regex to validate a JSON integer number. See what we get. So that says we should use an optional minus sign followed by 1 or more digits. So let's use that. We'll write ourselves in here, we'll duplicate this as int regex, and this is suggesting that string to regex. And if we were to convert it to a raw string literal, that would be a little bit nicer. Let's run that, see whether it works. And it does not. But our failing is, I think, in this numbers for each here, is that right? Yes, because we're iterating over the array list. So now I think we should probably just only be able to say that everything in our example file is a number. Try again. Good. Now, I'm a little bit suspicious because we do know that we shouldn't be able to parse numbers with a leading 0. And this doesn't look as if it accounts for that. Let's write ourselves a unit test for that. So we'll say that if we tried to parse, say, 042, then that should say that 042 is not a valid number. I don't think it will. And it looks like I'm right. And I think that means we'll probably fail now in our JSON Test Suite tests. So let's try the JSON Test Suite tests. And indeed we do fail those in an unexpected way. It's got to be said. I'll go back up the top and find all the failures. And well, it is numbers with leading zeros. There you are. So let's ask AI Assistant to change the regular expression. Change the regex to disallow leading zeros. Okay, so that says this thing. Let's take that, put it into here, convert back to a raw, run the JSON Test Suite tests, and that is happy. And then all of our other tests. And we still have an issue in JacksonTests, but it feels like we're getting closer. I don't want to address that yet because I think there are some more integer threads to pull. For example, we really should be using longs at some point. So let's think about that. If we have something that's bigger than int max int, so we'll have val bigger than an int, and we can make one of those by saying int dot max value to long plus 1. And now if we were to take that thing and put it into a string, then we would want that thing out of here. And just to check, this is actually a long. So what we expect to get out should be a long. Now, I don't think that will work yet. And we're now getting a number format exception for this string. And that's happening when we're trying to do parse int. Okay then, now we know that if we're in here, we have an integer, we just have to find a representation for it. But we could have any number of characters really. So I think maybe the sensible thing to do is to start by parsing it to long, and then narrow that to an int if an int will fix it. So that might be a function like to int or long. If that existed, it would return any, I suppose technically it would return number. And what would it look like? Well, I think it would say that if this is greater than int max value, or this is less than int min value, then we should return this, which is the long, else this to int. Run the test to find out. That's good, and we'll celebrate by making this an expression body. I think often whens are better in that case. Now we should add some tests for the boundary conditions. So we should say that expect that parse int dot max value is equal to int dot max value, and we can also say is a int. Run. That's good. Check that if we'd asked whether it was a long, it would have failed. Interesting, but let's do that anyway. We expected that to fail and it did. Good. So now we can return that to there. We also expect that min value will be min value that's bigger than an int. Let's do the same thing for smaller than an int, which will be int min value to long minus 1. And now smaller than an int is equal to smaller than an int. But again, we can put the test in here to say is a long. And we kind of know that has to be true, but I think it's good documentation. And run. Good. Now, what about ints that are bigger than a long? Well, val bigger than a long. We have a big integer that we can use for that. So we can say this is BigInteger dot value of long max value, and then we can add 1. Can we add 1? Maybe we have to do and, no, not and, but plus. We can only add another big integer. So we can say plus BigInteger dot of 1, and that's value of. So that's bigger than a long, and if we duplicate that and put that in there, it won't work yet, but we would like, if we parsed bigger than a long, then we get a big integer. That would be equal to bigger than a long. Run that, check that it doesn't just work miraculously. And indeed it doesn't. And that's because our string to long here is failing because the number is too big. Now we could parse with big integer and then restrict as we did here, or we can try with the long, and then if that fails, we can go on to the big integer. Given that almost everything I expect to fit into a long, I think I'm going to do the latter. So I'm going to use in here too long or null. So that if this can't fit into a long, then we'll get null out and we can use the Elvis to use BigInteger.parse. Oh, maybe not BigInteger.parse. Can we say string to BigInteger? We can. Now we could use to BigInteger or null, and maybe we should just in case. So we'll say to BigInteger or null. And if that is all still null, then we're going to throw, I think if that is still null, then our logic is wrong, because we know that it matches an int regex. So I think this is going to be error. I can say can't make an integer thing out of $string. How's that? Rather good. Not sure I like the double Elvis, but I'm going to suck it up for now. All right, let's add a test in here for smaller than a long. And we'll put that in there, and this is going to be long min value, big integer value of -1. And run. Good. Now there's one other awkward set of integers, which are things like, I'm just going to duplicate this one. If we have something like 12e2, so that's 12 times 10 to the 2. And the question is, should this come out as a big decimal because it had the exponent in it, or should it come out as an integer because it is actually integer? And this has come up recently with some AWS APIs where they're sending out timestamps as integers in exponential notation. So you'd get something like 1.2 by 10 to the 2, which is 120 and still integer. I think ideally I'd like this to be an integer, but that would mean taking our big decimals and working out whichever int, long or big integer we needed to extract from them. I think I'm just going to punt and say that even something like 1e2 is equal to a big decimal of 100. Run that. And it's interesting that big decimal doesn't consider 100 or 1 times 10 to the 2 to be the same number. I guess that's big decimal equality rather than ours though, so I'm just going to put that in there and pass like that. Okay then, let's return now to our Jackson tests. So now we believe that our 1 and -1 will be parsed correctly, but math.py, that's a problem. Now, given the difficulty representing decimal numbers in 2's complement doubles, I'm not sure that I ever really want a plain old double out of my parsing. So I think I'm going to go with that this should be math.py to big decimal, and that would allow this test to pass, and does. Good. I am just a little nervous right now that we've never tested 0. So let's just add ourselves a test for that. I think we'll say duplicate that one and say that if we parse 0, that should be equal to 0 as an int, and we'll say is int, run that, and that's true. And now straw that breaks the camel's back a bit, 0.0 is a big decimal, I think, and is equal to big decimal 0. Interesting that if I let the dot out of here, it turns out to compile but not, I suppose, run the right thing. So run those for real. Oh, wrong tests. Let's run all of our tests now. And once again, we have an interesting issue here around big decimal 0. And the issue here, I think, is that BigDecimals know how many significant figures they know, so that 0.0 is not the same as BigDecimal 0. So I think here we're going to have to say, I don't know, 0.02 BigDecimal. Interesting, try that. Well, that is true. I think that lot is worth checking in with. This is add JacksonTests and return integer types for integer numbers. Commit that. Couple of analysis, let's have a look at them. An unused import. Oh, surprised we haven't set that to automatically happen. Oh, and the version of Jackson we've got is vulnerable apparently. Let's fix that, shall we? 15.3. Import that. Check everything still passes. And it does. Check out JSON Test Suite tests still pass because they are disabled otherwise. And they do. And amend, commit that. Good. Right then, back in our Jackson tests, let's expand the range of things that we write out. I think maybe I'm going to make some lists of types of things. So we'll say in here, val strings is list of an empty string, a blank string. We know that strings can have \t for tab in them. We know that strings can have hello \n for new line world. We know that we can put a null in a string, so that would be hello \u 0000 world. It's complaining here, I think, because we already have some of those. So let's make this private. Some strings. This thing here, make a method out of it, which is check. And let's just add another test for strings. And in here was a check some strings. And run all our tests. Oh well, it looks like we and Jackson agree at least about how these strings should be rendered and parsed. How about some numbers? So I think we'll put in here 0, -1, 1, int max value, int min value, long max value, long min value, math.py to BigDecimal. Let's try those for now, duplicate that, and this is numbers. They are all happy apparently. Oh no, hold on, idiot, check some numbers. That might be too good to be true, but wasn't. I think we can probably now add in a few more things in here. I think maybe we'll put in 0, 0 to BigDecimal, and I think maybe something that will force exponential notation. Maybe if we said math.py to BigDecimal times 1 by 10 to the 7. What's its complaint here? Okay, so we need to say BigDecimal on our number as a string. Close that. Is that happy? It is, and we'll just check to see what sort of things we've got out in numbers here. Oh, and 1 times 10 to the 7 wasn't enough, so I think we'll say times 10 to the 100, see what we get. And there indeed we do get something in exponential notation, and it goes in and comes out. Right then, another jump a couple of 100 miles back to where I was, and I picked up a bit of a cold, which you might be able to hear, but let's crack on. What's our aim here? Well, it's to find combinations of things that might not work. And I think we want both breadth and depth. So we've tried some strings and we tried some numbers. I think maybe we'll add ourselves some booleans. So let's duplicate this as booleans. Check some booleans, which doesn't exist yet. And some booleans are a list of true and false. Don't honestly expect that to be a problem. Let's give it a go. And it isn't. And thinking about it, we'd like to check null somewhere. And I suppose the logical place of that is as a string. So let's put it in there and check that that's okay. Okay, so
In arrays, because we're checking a list in all these cases, we work for strings, numbers and booleans. But do we work for string, numbers and booleans at the top level? Well, we can use this framework to find out. So we could do strings, and we could say that we want to say for each in some strings. And in here we could say, instead of checking them all at once, we'll check them individually. So we could say check each. Why is that not compiling? Well, we had check take an any, not an any question mark, but we can fix that. So this will have individual strings at the top level. Let's run that. And that's good. And we can do the same for each of these other two. So we'll say that, that, and that, and that. Run that. Good. And now I think we could remove the duplication by creating a variable out of this things, and then make this into check things. Inline that. For some reason it hasn't given us the option of using, I suppose we made it list of boolean. That's silly. That should have been list of any question mark. And using that now we can say perform checks on some numbers, and in here we can say perform checks on some strings. Run that. Good. And perform checks, I don't know, maybe we'll call this check all. Now in this context, maybe our round trip at the top is a mixed thing. So I think we could use here, we could say check all, and we'll call this mixed. No surprises there. So now we're checking the primitive things in the context of themselves at the top level and inside an array. But we could also check each one of those as an element in a map. And because we're now writing a program to generate our test data, we can do it for all of our cases all at once. So if we put it in check all, here we've checked each one of these things individually, and we've checked the list of the things. In here we could build a map. So I'm going to say val map, and this is going to want to be a map of string to any question mark. And what I think we're going to do is we're going to say things map indexed, and we're going to use the index to build a key. So this is each. So our key will be, let's say, thing $index, and our value will be the thing, which is each. And we should be able to create a map out of that. And now we should be able to check that map. Run that. Still passes, and to give us an idea what we've tested now, let's have a look in the output. This is our JacksonTests, and you can see we've tested individual numbers, and then we've tested the numbers all together in an array, and we tested a map with each one of those numbers as the value with a generated key. And we've done this now for all of our data, and if we look down the number of lines in here, I suppose it'll give us the number of tests we've had. So we've had 39 tests now by the look of things. Now I'm sure somebody will be asking whether we should be building individual test cases for these. So if something fails, we have an individual test. Ideally that would be nice, but generally its parameterized test support isn't great. I think in this case it's probably more hassle than it's worth. If we find something that breaks, then we've got the tools to debug it. Especially as strict output here will show us what we put in and we put out. Putting each of our items into a map here reminds us that we could check each one of them as the only element in an array. So we could also say, as well as this thing, we could say for each in things, check a list of just that one thing. And when we're in this mode, the only real expense of adding a lot more tests is the runtime of the tests themselves. Okay, so one thing we haven't checked now is structures within structures, which is to say lists inside lists, or maps inside lists, lists inside maps, and so on. I think if we were to pull this code as a method, this would be to map and make things the receiver. Pull that out up into the top level. That would let us inline this. Just check it's all good. Oh, we have a failure. That's interesting. Let's have a look. Oh, Stack Overflow. That's weird. What have I messed up? Oh, of course, this map here is now calling itself because we've given it the same name. It's odd that the rename doesn't warn us about that, but I think if we rename this one here to be to map with names, say, then we can make this just the old to map and run. Okay, Now let's go back here, and I think we could write ourselves a test now. That is maps in maps. And now if we start with an input, in fact I think the simpler one would be maps in a list. So if we start with an input now, which is a list of, and now we'll go with some booleans to map with names, and some strings to map with names, and some numbers to map with names, then we should be able to call check on that input. And if we run just that one and look at the output, then you can see here we've got an array with a set of maps inside it. That's good. And I think we could probably do better here. We could say dot map it to map with names if we got rid of these in here. Inline that and run all of our tests. Good. What about lists in a map? Well, I think that's pretty much the same thing, except that we take the list itself and map that with its names. See what we get out of that by running it, what it passes, and here you can see now we've got thing 0 is an array, thing 1 is also an array, and so on. So that was quite easy, which is pleasing. What is maps in a map? Well, I think if we take this, and before we go on, what I think I'm going to do is I'm going to pull this input as a variable and show its type. So this is maps in a list because it's a list of map. Let's do the same with here. And I think we can tighten the type of this to list of any. Interesting, that doesn't work. And I suppose it doesn't work because to map with names, its type is too general. So I think we could say this is a fun of some sort of t. And if it's a list of that t, then what it gets out is a map with that t inside it. That makes this work, which is nice. And now here, what we want, let's just pull this thing out as a variable. We want an input whose type is map of string to map of string to any, question mark. And now I think we know the type of this is this list of map of string to any, and we can convert that to a map itself by calling to map with names. Tidy this up a little bit. And again, we'll just run this one to check that our output looks good. And there we have a map with some map inside it. Splendid. And that really just leaves lists in a list. So let's write something for that. We'll duplicate this. We'll say we want to show lists in a list. This wants to be a list, well, in fact, of any, but we can force it to be list of any. And if we take that out and make this a list of, with a list of some booleans and some strings, and then some numbers inside it, run that, check our output. So here you can see we've got the outer array and the inner array is that one, and then there's another one here at the top level. Okay then, now I think there's another systematic thing we haven't checked, and that's the name of keys. So I'm going to create a test from scratch, which is going to be key names. We should be able to cope with whatever way Jackson writes key names. So let's create ourselves some keys, and that's a list of, now pretty much any normal string should be all right, so we'll just say key. And we know we had some work to do around escapes, so with \t a tab, that reminds us that spaces with a space should be fine. New lines were another special case. New line. What about the empty string? That will be interesting. And let's just drop in some random Unicode characters. We know that a null might be an issue. We'll try ourselves whatever that is. And we'll go to the other end with FFFFF. And now we've got some keys. Let's say we want to build a map of string to something. So again, I think I'm going to specify the type, so I'm forced to be right. So this is string to any question mark. And we're going to start with our sum keys. And I think we'll zip those with something else. And we've got some values that we can just assign almost randomly. So I think we'll say sum strings plus some numbers. Now the type of that is a list of pair of string to any. So we should be able to say to map on that. And now we should be able to say check that input. Run just that. Passes, and let's see what we checked. So we checked key to an empty string, we checked with tab to a single space, we checked with a space to a tab character, we checked with a new line to hello world with a new line. So we've managed to get in sync here, I see, but everything seemed to write and read okay. So that's reassuring. Okay, so I think that's all the things I can think of, but what about the things that I can't think of? Maybe there's some combinations of things we can't cope with. Maybe we can't parse a Boolean after a string, or a null after a certain number of decimal digits, something like that. Now, there's practically an infinite number of things we could render into JSON and try out, but instead of doing more, what I think we'll do is we'll generate some random cases and see how we do. So let's warm up on arrays. I think we'll say test random arrays. Oh, and I think, yes, we said lists rather than arrays. I guess they're lists in Kotlin and arrays in JSON. So random lists. How do we generate a random list? Well, the first thing we have to decide is how many elements there are. Now, we could just generate a random integer, but that will be heavily biased towards very large numbers. There are simply more large numbers. So I think the approach I'm going to take here is to create a list of candidates. So I'm particularly interested in empty arrays, for example. Arrays with one thing in them, that would be interesting. Two things would be equally interesting. And after that, apart from running out of memory, we don't expect there to be any special cases. So I think maybe I'm going to go with 7 next as a sort of representative goodish number. And instead of elements, this I think is going to be element count. And what we're going to do is going to pick one of those at random. Now I think there's a list builder, so we want val input. And I think we can say list, giving it the size that we want, which is element count. And then that takes a lambda, which should yield the thing inside there. And I think that lambda, yes, it takes the element number there, but we're not particularly interested in that. What we want to put in here is a thing. Now, what do we want to put in here? Well, I think let's start by saying pick one of any of the things we've got, the primitives, at random. And then again, as usual, we'll run just this test. Eyeball whether we're doing a sensible thing. Oh, glad I checked, we're not. We're actually taking one of these things at random, each of which is a list, so we want to flatten that first. Run that. Oh, we've got an empty one that time. Try again. One thing in it that time. Again. A single empty string. I think this might be a case where JUnit can do better for us. If we say this is a repeated test, then we can tell it we'd like 100 of those and run. And now have a look. And you can see now that we are getting random lists and 100 of them. Now, a downside with this is that we are picking an empty list 1 in 4 times. Really no need to keep on checking that. I think we could probably say that we can bias this towards putting more things in by having 1 0, 2 1s, 3 2s, and quite a few 7s. Run that. And now, whilst we're still getting some empty ones, they will be relatively fewer. Okay, that's a good start. Now we know once we've got a list, we can make a map. So we could get ourselves some good tests by saying 100 times repeated maps. Our input is now going to be to map with names, and we can see what we get from that. And there we are, a few empty maps. Otherwise, maps with random data in. But no maps with maps and no maps with lists. Can we fix that? Well, I think what I'm going to do is I'm going to pull this thing out. Actually not this thing, but this thing as a method, which is random list. I keep on finding AI Assistant is getting in the way of those things. Let's just try that back there, right? And for some reason it hasn't seen that this is the same thing in here, but this is just going to be input equals random list to map with names. I'm not sure we've run all the tests recently, so let's just do that. It seems to have dropped off the list. Run all tests. Good. Now then, at the moment our random list only consists of Boolean, string or numbers, but we could put a list or a map inside it. So I'm just going to take this out of the middle of our tests. And now I'm going to take this thing here and say this could be random thing, where random thing is at the moment just a primitive. It's just inline. So what we want now is for random thing to pick either one of these things or a list or a map. I think in order to do that, we'll give ourselves a source of randomness. So we'll say private val random, and Kotlin now has its own random API, and I think it's random.default. And now we can say when random.nextInt with a maximum value of say 10, and now for now I'm going to say else. Fix that like that, reformat. And now I think maybe we'll say that if it's 0, then we will make it a random list. If it's 1, then we'll make a random list to a map. Otherwise for the other 8, maybe 9, I don't know what the ceiling is, we'll just pick one of our primitives. I think maybe that's going to bias things too much in favor of the primitives, so I'm going to turn this down to say 5. So now let's look at what random lists gives us. We seem to have messed up our syntax. Go again. Oh, a failure. Aha. So it looks like we're picking the random lists too often, and that it's possible for it to go down a path where it just builds a list and an object and a list and an object, or a list and a list and a list and a list. That's not good. I think maybe biasing our lists towards large numbers is not helping here. So I think I'm going to say let's only do 7 every now and again. See whether that fixes it. And it has. Let's look at what we actually did. And you can see it's gone quite well. We have a list here with an empty string to start with, then a map, which has some things, including an array with a single array inside it, and so on and so on. That's quite pleasing. Let's just look up and see the consequences of what we've done. Well, I think we were only using random list in the case where we were building something that was random list at the top or random map at the top. So we now have a number of structured and deterministic tests here at the top and some random tests at the bottom. Well, another thing I think we can do then is to take this random here, move it just above our random tests. Now, whenever we're using randomness in tests, the question is, if it fails, how do we reproduce it? We want to be able to reproduce the random sequence that we just had. Now, it would be nice if we could get the seed from a Kotlin random, but we don't appear to be able to. What we can do instead, though, is initialize it with a seed that we know. So we can call random constructor, which takes a long, and we can use system current time millis as that long. Now then, if we pull this into a field of random seed, then we can print it out at the beginning of our tests. And we'll want to make sure that everything uses this random. What do we have? We have random list, random. This random here, I think we can pass the instance of random into that. Yes, we can. Good. And this is using our random, and this one here needs to as well. Good. And now if, for example, we were to run this test, there it is. We'll pin this, take this random seed and pipe it into there, run again, and now we have well, every test repetition doing the same thing, but that thing should be the same as the first one in this one. So let's have a look. This number was 2147, and there it is, the same thing. Okay, so I think we should be able to put random seed back in there, and now things do go wrong, we'll be able to reproduce them, but otherwise every time we run this, we'll be trying a different set of structures. I think maybe we'll print that out, not here at the top level, but let's take this thing and put it here and here. Run that, and now individual tests will tell us the seed before they run. I think we could do now, finally, without the print in here. And last but not least, let's run the tests for the JSON Test Suite, which are disabled because they take this long. And fail. But that's a deliberate failure because we know that we are actually throwing Stack Overflow error rather than legal argument exception. So that is our last to do, I think. So I think let's commit this as lots more Jackson tests. Splendid. I'm quite pleased with these Jackson tests. I suppose I'm especially pleased that we didn't actually fail any of them, but I feel that we've now got some pretty solid coverage. Thinking it through, we're only actually testing the way that Jackson serializes, so we could be broken with respect to white space and that sort of thing. I wonder if maybe we should use Jackson's pretty printer to check that we work with that, but on the whole I think this is quite a bit of due diligence. I suppose you can see the whole test suite as a property-based test where we're testing one property, where that property is that if Jackson writes something, we read the same thing. Despite falling view numbers, something you could do something about by pressing the like button, I think I still have some work on this project to do. I'm not entirely happy with our top level thing here. It feels to me like we should be able to have a top level state like these other ones that encapsulates effectively this loop. And there's really quite a bit of duplication in here. Maybe something else is trying to get out. I'd also like to performance test what we've got. I'm now reasonably convinced that it's correct, but I don't know whether it's fast. So next episode I think we'll measure, maybe do a little bit of optimization and a bit more refactoring. My happy place. If you'd like to see me happy, then please subscribe to the channel, like this video so that I know that you do, and run, don't walk, to buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.